These are solutions to Melham's Calc 3, Math 110C final exam at City College. Number 1, cosine of theta is u dot v over norm u norm v, negative 4 plus 0 plus 6 over square root of 1 plus 9 plus 4, square root of 16 plus 0 plus 9, 2 over 5 radical 14. Theta is inverse cosine of 2 over 5 radical 14 to the nearest degree, 84 degrees. Number 2, form the vectors PQ, 111, PR is 437. Area is 1/2 the magnitude of PQ cross PR. PQ cross PR, IJK, 111437. So the I component is 7 minus 3. J component is the opposite of 7 minus 4. K component is 3 minus 4. So 4, negative 3, negative 1. Magnitude of PQ cross PR is the square root of 16 plus 9 plus 1, radical 26. So the area of the triangle is 1/2 of radical 26. Number 3, the direction vector is delta x, delta y, delta z, or 2, negative 1, negative 7. So x is 2 plus 2t, y is negative 1 minus t, z is 3 minus 7t. Solve for t. T is equal to x minus 2 over 2 plus equals y plus 1 over negative 1 equals z minus 3 over negative 7. Number 4, r prime is 4, 3 cosine t, negative 2 sine t. Plug in pi over 6. 4, 3 cosine pi over 6, negative 2 sine pi over 6. Cosine of pi over 6 is radical 3 over 2, so 4, 3 radical 3 over 2. Sine of pi over 6 is 1/2, so negative 1. So unit tangent, is 4, 3 radical 3 over 2, negative 1 over the square root of 4 squared, 16, plus 3 radical 3 over 2 squared is 27 over 4, plus 1. This is radical 95 over 4. Multiply top and bottom by 2 to simplify. So 8, 3 radical 3, negative 2 over radical 95. Number 5, the length of the arc is square root of dx dt squared plus dy dt squared plus dz dt squared, which is square root of 2 squared is 2. E to the t squared is e to the 2t. Negative e to the negative t squared is e to the negative 2t. This comes out to be e to the t plus e to the negative t squared, whose square root is e to the t plus e to the negative t. Integrate e to the t minus e to the negative t. Plug in 0, you get 0. 1 minus 1. Plug in 1, you have e minus e to the negative 1, which is the final answer. 6, r prime is t squared 2t2. T of t is t squared 2t2 divided by the square root of t squared squared, t to the 4th, plus 2t squared, 4t squared, plus 2 squared, 4. Okay, this is t squared plus 2 quantity squared. So t squared 2t2 over t squared plus 2 is the answer to t of t. This can be written as 1 minus 2 over t squared plus 2. This one, the middle one, leave alone. This is 2 times t squared plus 2 to the negative 1, okay, which means the derivative of this and this would just be opposite. You know the derivative is 1 is 0. This is negative 2 t squared plus 2 to the negative 1. So the derivatives here are opposites. So this is going to be, well, let's do this. The derivative of this is negative 2 t squared plus 1 to the negative 2 times 2t, or negative 4t divided by t squared plus 1 squared. Okay, so since these are opposites, that makes this one 4t t squared plus 1 squared. This one, quotient rule, bottom times derivative of the top, 2, minus the top, 2t times derivative of the bottom, 2t, over t squared plus 2 squared. A little bit of algebra, 4 minus 2t squared for this one. Okay, now to find a unit normal vector, you can take any scalar multiple of this. A scalar multiple is to lose all the denominators. So I just ignored the denominators and took out 1/2 from the numerators. So I made the new vector 2t, 2 minus t squared, negative 2t, which has the same direction as this thing, divided by the square root of 2t squared, 4t squared, plus 2 minus t squared squared, plus 4t squared. Okay, a little bit of algebra. This is t to the 4th minus 4t squared plus 8t squared. So it becomes plus 4t squared plus 4. And this factors in a t squared plus 2 squared. So final answer is 2t, 2 minus t squared, negative 2t over t squared plus 2 quantity squared. So that's the answer to number 6 for the unit normal. Okay. 7, fx is 3x squared y squared minus 9x squared y to the 4th. Fy is 2x cubed y minus 12x cubed y cubed. Fxx, 6xy squared minus 18xy to the 4th. Fyy, 2x cubed minus 36x cubed y squared. Fxy, which is the same as fyx, 6x squared y minus 36x squared y cubed. Number 8, z sub x is negative 2x, z sub y is 2y. Plug in 5, negative 4, negative 9, which really means only plug in x, negative 10. Z sub y at 5, negative 4, negative 9. Plug in negative 4, you get negative 8. So z minus a minus 9, z plus 9 is negative 10, x minus 5 minus 8, x plus 4. You could have left it like that, a little bit of algebra. 10x plus 8, 10x plus 8y plus z equals 9. Should be y's here. Oh, well, what it would be like, you knew I had to mess up in order to make the class authentic, I guess. Those should be y's. Okay, number 9, unit normal vector is negative 4, 7 divided by the square root of 16 plus 49, negative 4, 7 over radical 65. Fx is 2 radical y, plug in 3, Fx is 2 radical 3. Fy is x, y to negative half, or x over radical y at 2, 3. Fy is 2 over radical 3. So derivative of u in the direction, derivative of f in the direction of u is del f dot u, gradient vector dot u. So 2 radical 3 times negative 4 over radical 65 plus 2 over radical 3, 7 over radical 65, which is negative 8 radical 3 over radical 65 plus 14 over radical 195, multiply top and bottom by radical 3, negative 10 over radical 195. Number 10, e to the x squared plus y squared is e to the r squared, r dr d theta. R goes from 0 to 1, theta goes from 0 to pi over 2. Here's the picture. And multiply by 2, multiply by half. So a u substitution, u would be r squared, d was 2r dr. So I can go straight to the next step of being e to the r squared. So I have, see, pi over 2 is the length of the theta interval. There's no theta involved here. So pi over 2 times a half, e to the r squared from 0 to 1. So pi over 4, plug in 1, you get e, plug in 0, you get 1. So pi over 4 times e minus 1. Number 11, square root of x squared plus y squared is the square root of r squared, or r. So that's r. And then r dz dr d theta. Z goes from negative 3 to 5. R goes from 0 to 5. The cylinder was x squared plus y squared equals 25. Theta goes from 0 to 2 pi. This thing doesn't depend on z. Take it out. The length of the interval is 8 for z. This thing doesn't depend on theta. Take out the length of the interval, 2 pi. 2 pi times 8, r squared dr. So 16 pi r cubed over 3 from 0 to 5. Plug in 0, you get 0. Plug in 5, 16 pi over 3 times 125, 2000 pi over 3. Number 12, spherical coordinates. X squared plus y squared plus z squared is rho squared. Here, rho goes from 0 to 2. So rho squared times dv, rho squared sine phi, d rho, d theta, d phi. Phi goes from 0 to 2, theta goes from 0 to 2 pi, phi goes from 0 to pi. This thing doesn't depend on theta, so take out the 2 theta. Take out the 2 pi theta. Rho to the 4th sine phi, d rho, d phi. So rho to the 5th over 5 sine phi, rho goes from 0 to 2. Plug in 0, you get 0. Plug in 2, you have 32 over 5. Integral from 0 to pi of sine phi d phi, 64 pi over 5, negative cosine theta from 0 to pi, which is negative 64 pi over 5. Cosine of pi is negative 1. Cosine of 0 is 1. Negative 1 minus 1. Negative 2 times all that, 128 pi over 5. 13, f is x squared y cubed, so t squared squared, negative t cubed cubed, and then t cubed y radical x, so t cubed radical t squared, or negative t to the 4 plus 9 13th, t to the 4th. dr, which is r prime, is 2t negative 3t squared. F dot dr is negative 2t to the 14th minus 3t to the 6th. So I want the integral from 0 to 1 of negative 2t to the 14th minus 3t to the 6th, negative 2t to the 15th over 15 minus 3t t to the 7th over 7 from 0 to 1. Plug in 0, you get 0. Plug in 1, negative 2/15 minus 3/7. A little bit of arithmetic. Negative 59 over 105. 14, partial of q with respect to x equals the partial of p with respect to y, which is 5. Therefore, we have a conservative vector field. Fx is 6x plus 5y. F of xy is 3x squared plus 5xy plus g sub y, not g of y, g sub y. So Fy is 5x plus gy, which is 5x plus 4y. That means 4y equals g sub y, or g of y is 2y squared plus k. So f of xy is 3x squared plus 5xy plus 2y squared plus k. That's my anti-gradient. You can double check. The partial with respect to x is that, and the partial with respect to y is that. Finally, 15, use the divergence theorem. The divergence of f is p sub x plus q sub y plus r sub z, which is 0 plus 9x squared z squared plus 0, or 9x squared z squared. So triple integral of the region E of the divergence of f dv is triple integral negative 1 to 1 for x, y, and z of 9x squared z squared dy dx dz in some order. I pick y first because this doesn't depend on y. So just take out the length of the interval y, which is 2, and also take out the 9. So I integrate with respect to x. So negative 1 to 1 for z, x cubed over 3 times z squared. X goes from negative 1 to 1. Combine the 3 with the 2 times 9, or 18. That gives me 6. Plug in 1, I get 1. Plug in negative 1, I get negative 1. So 1 minus a negative 1, z squared dz. That gives me 6 times 2, or 12. Integrate z cubed over 3 from negative 1 to 1. 12 divided by 3 is 4. 4 times 1 minus a negative 1. Final answer is 8. Okay, and for one last time, let me do the focusing job. And while I'm doing this, I'll just mention that I hope you enjoyed the course. You are one of my best classes, as it turns out. I ended the class with 42 students. I normally over enroll, thinking that, okay, if I get up to say 45 students, there's always going to be 10 that drop. But very few dropped, so I'm glad that a lot of you made it through. I think I had a very good class. And frankly, it was my opinion that some of you were better students than I was a teacher. Some of you made fewer mistakes than I did. I was making mistakes left and right, as a lot of you no doubt know. So here was all that. And I think I didn't make any mistakes too egregious on this final exam, but if it happens, I'll let you know. Right, so I hope you enjoyed the class. Thank you for being a good class. And you can still always contact me at mhom@ccsf.edu. And let me get through all of this. Okay, so it was a pleasure having you all. And once again, thanks for this. I still don't know who was in charge of giving me the headset. I'll just say collectively, thank you. Gave me the headset, I certainly appreciate it. All right, so that's it for our course, and hope you enjoyed it, and everybody have a good summer. Bye.